Hello, in this video, we are going to begin developing predictive models. For this, we're going to refer back to a data set which we created in previous lectures. And this data set was the insurance data set, and we have already scrubbed this data set. So if you recall, there are two targets for this data set. The first target is, did the person crash their car? And if the number is a 1, they crashed their car during the time of their insurance policy, and a 0 means that they never crashed their car. The second column here is the amount it took to fix the car, so the amount of money. So this person did not crash their car, so obviously it didn't cost us anything to fix it. This guy did, and it cost us $5,970. Now, all of the other variables in this model are variables that were collected. This is information that was collected when the insurance policy was written. And there's all sorts of things that they ask you when you are asking for insurance. They ask you things like, how many times have you crashed your car, and do you like to speed, and things like that. Now, in previous lectures, we have taken and scrubbed this data set. And by scrubbing it, it means that what we did was if there were missing values, we fixed those missing values by estimating what the value might be. That was called imputing. We also created flag variables like this one here and this one here, because sometimes the fact that data is missing can be highly predictive. So we're going to use those as input variables. And then furthermore, we had categorical variables, things like if we move down here, we had things like what kind of job do you have? Do you have a blue-collar job? Do you have do you live in the country, or do you live in the city? Things like that. So these are categorical variables, and we converted these into flags, 1s or 0s. So if you are a lawyer, this was set to 1, and if you're not a lawyer, it's set to 0. So we're going to use all of these variables, which have now been converted into numbers, and we're going to see if we can use these to predict whether or not a person is going to crash their car. So let's close this down, and let's open up R. Now, for this exercise, we are going to use possibly one of the most simple of all predictive models, and this will be a decision tree. And we're going to use a very simple decision tree to figure out if a person is going to crash their car, or what is the probability that they're going to crash their car. So let's start off by reading in the data set that we've just looked at a few moments ago. So let's read that data in. We're going to read this into R. And the data is located here, and this is the data set, and we've now read it in, and it's being stored in a data frame, which we are going to call DF. And we could call it anything we want. Now, if I type in head DF, this is going to give to me, there we go. So this is going to give me the first 6 records. And you can see here again, we have the target and this target, and we have all of the other variables, and none of them are missing. There's no missing values out there, and we don't have anything other than numbers. And the decision tree is going to love this data. So now, what do we do here? Well, let's quickly look at the structure of the data. And this is just a best practice. You don't have to do this, but this is what I usually do. I'll look at the structure of the data and just want to give it one last look to make sure that this is all numerical data, and in this case it is. And these are, look at all the variables. We have a lot of variables in this model. And the other thing you can look at is a summary of the data. And when we summarize the data here, I like to look at it real quickly to make certain that we don't have any variables that have missing values. So it'll tell me if I have any, and we don't because we fixed these before. So now we're ready to actually build a predictive model. So let's go over here. In fact, let's do this first. Let's do this guy. Now, we've already read in the data. And there it is. So this is DF data frame is going to be our original data set. And I don't want to mess with that. I want to leave that as it is. So what I want to do is I'm going to make a copy of this data set because I can't have two targets in this model. I only can predict one thing. I can either predict, are you going to crash your car? Or I can predict how much it's going to cost to fix your car. So I'm going to do one of those two things. In this case, a very simple model is going to simply be, are you going to crash your car? So we're going to go with that guy right there. So I'm going to have to get rid of this guy right here. So what I'll do is I'm first going to make a copy of my data frame. There. So now I've got this guy here. He's a copy. Data frame flag is going to be a copy of this guy. And then I want to get rid of this guy right here. I don't want him anymore. So let's get rid of him. And we do that by setting him to null. So now if I do head data frame flag, you can see that my other target variable is gone. We only have this guy to work with. And now we're ready to go. So we are going to use a package in R called rpart, and it stands for recursive partitioning. So at the very top of this file, I read in rpart. And this is going to allow me to use decision trees. I'm also going to read in a second library called rpart plot. And this is going to allow us to print or display the decision tree. And finally, we're going to read in this guy, which is going to allow us to build or print a ROC curve, which we're going to use to determine how accurate the model is. Now, these may not or might not be installed already in your installation of R. So if you recall from previous lectures, you're going to have to install those. It's actually a very simple process. I have them installed already, but I'll show you just to refresh your memory if you don't know how to do it. You just go up here to Packages in your R environment, and you click on that, and you first set a CRAN mir. CRAN is a repository of these packages. So we do that, and I click on Set CRAN mir, and up comes a list of all the places around the world that they have our repositories. They're all the same. They ask that you choose one close to you to save cost. So I live near this guy, so I'm going to select him. But if you lived in, let's say, Madrid, Spain, you would select this. There's no problem. If I wanted to select Madrid, Spain, I could do it with no problem, but they ask that you select something close. So I'm going to do that. So I'm going to select Ohio. And then I would go over here and I would install the packages. And when I do that, up comes a list of all the packages that are currently in R, and there's thousands and thousands of these. Some are better than others. R part happens to be a good one. So I'm going to go way down here. They're alphabetical. There's no fast way of going through this list other than scrolling. But I will go down here and eventually hit find R part. And it should be very close. There it is, R part. Well, we already had that installed. But if you wanted to do R part plot, you can do that. And then you would just hit OK. Now it's been installed already on my machine, but if it weren't, I would just hit OK, and it will go through the process of installing. Now it's going to say in this case, you know, I had already installed it. So let me load these libraries in. And I'm going to just load all this stuff. There we go. Now, I'm going to tell the decision tree, you don't have to do this next line, but I like to tell this decision tree, for our purposes, the purposes of this demonstration, I want to limit the size of my decision tree to 3 levels deep. So I'm going to just tell R part control, and I'm going to set this variable to a control variable, and I'm going to say, hey, listen, don't let this decision tree go any deeper than 3 levels. There's all sorts of different parameters you can set on your decision tree to make, control how it is generated. You can simply take the defaults and completely ignore this step, but for this demonstration purposes, I don't want a very large decision tree. So we're going to just do this. And now we are going to create a decision tree using R part. So R part is going to recursively partition our data. We're going to use this data set right here. And this was the data set we created up here. And then we got rid of the claims amount. So there, we're going to do that. Our target for this is target claim flag. And if you recall, let's look up here. That's this guy right here. He's let's go up here. He is the guy that says, did you crash your car or not? Now, let's head DF flag. There we go. So you can see that this is the guy who says, did you crash your car, yes or no? All of the other variables are the ones we're going to use to try to predict whether or not the guy is going to crash his car. Now, so I have to type in this because that's my target, and then I put a little squiggly thing here, and this is usually found in the upper, it's called a tilde, and usually it's in the upper left-hand corner of most keyboards, but depending on, what kind of keyboard you have, who knows where it's located. But it's usually located near the number 1 on your keyboard. So you put that guy, so you put the target, you put the little squiggly guy there, and then I could list every single one of these variables and put a plus sign in between. So I would put kids drive plus, home plus, blah, blah, blah. And I could put all of those guys in there if I wanted by hand, and it would be a very long line. Or R will let me use a shortcut of just putting a dot there, and R is going to say, okay, I'm going to use every other variable except this. So if I have all of the other variables are going to be used to predict this guy. And then, of course, remember him, this is where we said, hey, don't let this get any lower than 3 levels. So I'm going to say, and by the way, control this decision tree using this variable, and this variable is right here, 3 levels deep. So let's do that. And let's make this small. So I'm going to do this, and I'm going to hit the carriage return. And at this point, decision trees are lightning fast usually to create. So I've got this guy, and he's created. And so now what we're going to want to do is we could just type in, whoops, if I type in tree flag, this gives me a series of if-then-else rules about my data set and how we can predict it. But this doesn't tell us a lot. I mean, you could look at this and try to figure out what's going on. But what we're going to do is instead we're going to visualize the decision tree. And for that, we're going to use our plot. And here we have the decision tree flag, or, the decision tree that we created, decision tree flag. I could have named this anything I want. I could have named it Fred, Joe, Mary, whatever. I'm going to name it tree flag. And I created the tree and I stored the results right here. Now I'm going to print this decision tree. And this is where it gets really interesting. There, take a look at that. Now, what this is telling us is that if I don't know anything about you, you have a 27% chance in this data set of crashing your car. Now that's a lot, but this is real data incidentally, but it's probably a subprime, a discount auto insurance company that probably deals with people with bad driving records. I don't know, but 27% is quite high. But anyway, this is 27% or 0.27 is the number of your chances of crashing your car. Now, a decision tree is nothing more than a series of if-then-else statements. And it's going to partition the data that way. And the first thing the decision tree, it looked at all the variables and it decided that the best way to figure out if you're going to crash your car is to say, how much money did we spend in the last, I think, 3 or 5 years, something like that. Let's say 3 years for right now. And it's going to say, in the last 3 years, how much money did we spend fixing your car? In other words, did you have a lot of crashes in the last couple of years? If it's less than $531, in other words, we didn't have to fix your car very much the last couple of years, that means you're a safe driver. And if you were a safe driver the last 3 years, yes, you were safe. Your chances of crashing your car went from 27% down to 18%. But what about the people who crashed their car and we had to fix it a lot? Well, those people, their chances of crashing their car went from 27% to 41%. So if you crashed your car a lot in the past, you're going to crash it in the future. So I could stop the decision tree right here. But we said go down 3 levels. So let's go down to the next level. So on this side, we said, oh, by the way, do you live in the city or do you live in the country? Well, if you live in the city, that's an urban, and your value would be set to 1. And if you live in the country, that number is set to 0. So is this set to 0? In other words, do you live in the country? And if you live in the country, your chances of crashing your car drop from 18% down to 4%. And then over here, if I live in the city, my chances of crashing my car goes up to 23%. And that makes a lot of sense because, there's no traffic in the country and there's lots of traffic in the city. Now, we finally look over here and we say, well, what kind of job do you have? Do you have a salary job or do you have an hourly job? People who have a salaried job, in other words, a doctor or a lawyer, those people tend to crash their car less, 23% down to 13%. And people who have an hourly job tend to crash their car more. The reason for that is that people who tend to have a salary job drive their cars less. The less time you're in that car, the better. Means you're not crashing the car. We look over here. These are the people who we've crashed their cars in their past. The people who crashed their car in the past, salary job is a biggest predictor. And we can look at this and we can say, well, if I have a salary job, my probability of crashing the car goes to 29. Otherwise, it goes up to 47. This percentage number here is how many people are in these buckets. So over here, when I don't know anything about you, it's 100%. When I get down here to the lowest levels, I say, well, this guy here is 18% of the people are safe drivers who live in the country. Over here, I have risky drivers who are hourly employees, and that's 25% of the population. So this is what a decision tree does. We're going to, in future lectures, talk about how these come to be, but this is how they work. Now, the neat thing about a decision tree is it will tell me how important variables are. So I can come over and ask the decision tree, hey, listen, would you please tell me how, when you were just figuring this out, what variables do you think are the most important? And so the decision tree thinks that the most important variable is oldest claim and frequency. In other words, did you crash your car a lot? Salaried workers, urban, MVR points as your speeding tickets, etc. So these are the variables. There's a big list, but these are the only ones that the decision tree happened to like, that thought that these were the most predictive. We can use these later on for variable selection, but let's just know that the decision tree is pretty good at saying what's predictive and what is not. Furthermore, and we're going to talk about this in other lectures, we can generate a ROC curve to predict or to show us how accurate this is. So let's just do a quick ROC curve. And when I do that, we get this curve right here. And we'll explain this in another lecture, but this diagonal line is the accuracy of randomly guessing. So this is just like pulling names out of a hat or rolling dice. If I wanted a perfect model, this is a model that uses like a magic 8-ball, or you get Karnak the Magnificent or some amazing fortune teller. They'll say that there would be a line that goes way up here to the number 1 and all the way across. And this one here is like a bow, like a bow and arrow. The greater the bow, the more accurate is the model. So this is a pretty good accurate model. It's got a nice, it's clearly more accurate. All this white space underneath is the accuracy of the model. And I can ask the model, what's the area under that ROC curve? And that's usually a metric that a lot of people will use. So I can just paste that right there and then type in AUC, and that's 72%. So you can see that 50% is the area under the ROC curve if I'm guessing. But if I'm using my model, it's not 50%, it's 72%. So this is the area under the ROC curve from my model. Perfect model would be 100 or 1.0. Random is 50%. So anyways, this is an overview of just building a simple model. We're going to go into more depth on how this is done in later videos, but I want to walk you through the big picture right now.